Hello and welcome. Today, we're diving into the world of synthetic fuels, also known as e-fuels. These fuels are a hot topic because they offer a promising way to clean up sectors like aviation, shipping, and heavy-duty transport, where just switching to batteries isn't easy. So, how are these e-fuels made, and what makes them a potentially green solution? The production process is quite fascinating. It starts with capturing carbon dioxide. This CO2 can come from industrial emissions, or even be pulled directly from the atmosphere. At the same time, we need hydrogen. But not just any hydrogen, we need green hydrogen, which is made by splitting water using electricity from renewable sources like solar or wind power. Once we have our captured CO2 and green hydrogen, they are combined through chemical processes. Common methods include Fischer-Tropsch synthesis, which can produce e-kerosene for jets or e-diesel, and methanol synthesis, which creates e-methanol, a fuel gaining traction in the maritime industry. Two concepts are absolutely central to e-fuels being sustainable. First is CO2 valorization. This means we're taking captured CO2, which is normally a waste product and a greenhouse gas, and turning it into a valuable raw material for our fuel. It's about creating a circular carbon economy. Second, and critically, is the use of renewable energy. The entire production chain, especially making that green hydrogen, must be powered by renewables. If we use fossil fuels to make e-fuels, we defeat the purpose. So, why are e-fuels generating so much excitement? Well, when made correctly, they have the potential to be nearly carbon neutral. The CO2 released when they burn is roughly equivalent to what was captured to make them. Many e-fuels are also drop-in ready, meaning they can be used in existing engines and infrastructure with few or no changes. This is huge for decarbonizing planes and ships where batteries aren't practical due to energy density needs. E-fuels can also act as a way to store surplus renewable energy for later use. And, importantly, their production doesn't necessarily compete with farmland used for food, especially if CO2 is captured from the air. However, there are significant challenges. Currently, e-fuels are much more expensive to produce than traditional fossil fuels. Scaling up production to meet global demand will require massive investments in renewable energy capacity and CO2 capture technologies. The overall energy efficiency of converting renewable electricity into a final e-fuel product also needs to improve. Supportive government policies and clear regulations are crucial to encourage investment and help e-fuels become cost competitive. Despite these hurdles, the outlook is positive. Numerous pilot and demonstration projects are underway worldwide, pushing the technology forward and aiming to bring down costs. With the continued decline in renewable energy prices and ongoing innovation in capture and synthesis techniques, e-fuels are poised to play an increasingly important role in our journey towards a sustainable energy landscape. It's definitely a field to keep an eye on. Thanks for listening.